Okay, next topic to discuss is Diffie-Hellman RDH. Basically, Diffie-Hellman is a key agreement algorithm which was developed in the year 1976 by two doctors, Diffie and Hellman. That's why the name is Diffie-Hellman, by two mathematicians, and they developed this algorithm in the year 1976. And Diffie-Hellman is a key exchange method, and it is a super mathematical algorithm. Why? Because Diffie-Hellman allows two parties, when they don't know each other, they can generate the same secret key. It means Diffie-Hellman allows two devices to establish shared secret over unsecure network. Diffie-Hellman key agreement algorithm is widely used in security protocols such as IPsec. It means we widely use Diffie-Hellman and site-to-site VPN and remote access VPN. Also, Diffie-Hellman algorithm is used in secure shell, which is SSH, also in transport layer security TLS and SSL. It means only two parties involved in the DH key exchange, and the key is never sent over the wire. So it means they will use such method that you will never exchange the key with each other. There will be mathematics involved, and you will generate shared secret key which will never be sent. So this is the beauty of Diffie-Hellman. Suppose me and you want to do a secure communication, but the first thing which we need to exchange the key. Now this is the thing how I can exchange the key to start the encrypted traffic. Suppose me and you want to do secure communication, but to start the secure communication we need a secure key. Now how I will send the secure key first time? So there we need Diffie-Hellman. You will exchange some mathematics things which I will show you a bit later, and it will generate a shared secret which will never be sent over the wire. This is the beauty of Diffie-Hellman. So such as firewall, Cisco firewall and router and other firewall, they use group 1, 2, 5, 14, 15, 19 and 20s. It means higher the group number, the more secure you are, and require additional time to compute the key. So these are the group, just they give them the group 1, 2, 5, 14, 15, 19, 20. By the way, there are multiple Diffie-Hellman group from 1 to 30 which is assigned, and there is from 31 to 3 to 7, 6, 7, these are unassigned. So there are many groups. The more higher, the more you are secure and the more stronger key, but it requires more CPU and more time to compute the Diffie-Hellman key. Cisco router and firewall support 768-bit up to 1024-bit Diffie-Hellman group. And those groups are this one. Diffie-Hellman group 1 is 768-bit. And it is recommended not to use this one. There is a Diffie-Hellman group 2, 1024-bit. There is a Diffie-Hellman group 5, 1536-bit. There is 14, 2048. There is group 19, 256. Now these groups are using elliptic curve, which is a next generation method. So these are require less CPU but more stronger than these one. These are the typical one. This one is the elliptic curve, the next generation encryption method. So these encryption method, they 256 but is better than 768 bit up group 1. Maybe you are thinking that this is 384. This is the beauty of the elliptic curve next generation encryption. It requires less but more stronger. So this is Diffie-Hellman 20, 21 and 24. So it means there is group 1 to 30. Many devices support up to 24, and you may see in many firewall and also in Cisco routers these groups. So these are just, they give them the group, the more stronger, the more higher, the more stronger, if you want to use Diffie-Hellman. Okay, so these are the group 1 to 30. Let me show you in router and some firewall these group number. So let me go to 40 gate firewall, and if you go to VPN settings, so there is Diffie-Hellman group. This one support 1, 2, 5, 14, 15, 16, 17, 18, 19 and up to 27 and up to 32. It means it support more than, because these are unassigned but now it started. So there are group from 1 to 30. So it means this 40 gate firewall support these Diffie-Hellman group. And also if I can see in phase 2, so in phase 2 is also support Diffie-Hellman from 1 to 32. Let's go to router. And router, if you go to CryptoISA CAM policy 1, and there is a group. Basically this group means Diffie-Hellman group. And I put a question mark, so it support only 1, 2 and 5. Because this is an old router 3725 model router. So it support only these 3 group. 1, 2 and 5. 1, 2 and 5, these 1, 2 and 5, which has to be avoided and which is not recommended to use, because these are the old one. So you get the idea. Okay, so now you understand what is a Diffie-Hellman. Let me show you from the example. Let's take this example, how it will work. Suppose this is device 1 and this is device 2, and they want to do a secure communication. But how they will start? So they need a Diffie-Hellman to generate a share secret, same share secret key. How they will do? Consider in the middle, this is internet and hackers are there and they can see these value which is in the middle. But those values such as private, they will never exchange and neither they will see. So how they gonna start? They need 2 number. One is prime number, another is a generator. So these 2 parties agree, prime number is 13 and generator is 6. Suppose this is a small number. In real world, in VPN it will be a huge number. I will show you. So this is a prime number 13 and generator 6. It means in the middle the person know these 2 value and these 2 also know. So they decide these 2 number. Now these 2 party will generate a random private key. Now these keys are not yet exchanged, keep in mind. Only these 2 value the hacker can see, 13 and 6. Now this side they decide private key 5. While this side they decide private key 4. They can decide any key, anything. Now what these 2 party will do? They will take the generator and in the power up their private key. So let me take the calculator. So the the generator number is 6 and power the private number which is 5 and equal. So this is 7776, this one 7776. Now they will mode them with prime number. Prime number is 13. So there is a mode and 13 equal 2. So the public value is 2. Now they generate this key. In the middle 13 and 6 know by the hacker, but hacker don't know the private key. They generate this key and they will exchange this 2 with the other side. Similar this side, they will do the same calculation. Same calculation, what they will do, they will take the generator which is 6, let me clear this one, and with private key. So private key is equal 1296, yeah, and mode 13, which is a prime number 13. So their public key is 9 because their private is 5 and this private is 4. So the public key are different. Now they will exchange the public key. Again, the middleman, the hacker, they know 13, they know 6, they know value 2, and they know value 9. So they get 13, they get 6, they get 9, and they get 2. Now they exchange the public key with each other. Now in the next step, what they will do? 9, the public key which is get by the other party, they will use their private key. Now the hacker don't know the private key because they never exchange the private keys. The hacker till now know 13, 6, 2 and 9. So 9, let me do this one and let's clear this one. So 9, which is a public key of the other party, and 5 is the private key. Power up 5, so the value is 59049. Now in mode 13, again the prime number. So the value, the share secret key is 3. Similar when they exchange 2, so the value is exchange 2, okay, and power by their private key. So the opposite is 16 and mode 13. 13 is the number, so mode 13, and finally they both have the same share secret. Do you think the hacker can do something with these value to get 3, such as 13, 6, 2 and 9? That's it. Because these two parties never exchange private 5 and private 4 number with this unsecure channel, but they make a mathematic algorithm and finally they get the share secret. So it means both Alice and Bob, we will consider this is normally we say this is Alice and this is Bob, were able to attain the same share secret of 3. Anyone listening in our their DH key exchange would only know the public value and the string P and G value. So it means they only know 13, 6, 2 and 9, and they will never use any mathematics, any algorithm to get 3 value. It's not possible by this person. Now let me show you from the crypto tool how it is work. So this is the crypto tool, and let's go to put the same value which we have. So what was the value? It was the number is 13 and 6. So let's get let's start, okay, and let's prime module is 13 and generator is 6, okay, and accept the parameter, okay. Now choose the secret key. So this key by this person they choose 5 this side. So let me choose 5, and this side this person get 4 and accept. Now create share secret key. This the now this the things with mode 6, 5 and this one. So let's generate and click OK and calculate. So the value is 2. Yes, it's true. The public key is 2 and this side it will be 9. So let's generate. This is 9. Now exchange the share secret. So they exchange 2 because they will exchange 2 and they will exchange 6. So now 2 and 6 is being exchanged, and now finally they will use this method to find out the share secret, and it has to be the same, and click OK and calculate, and let's see, finally they get 3 and if this guy do the same thing, look at now is 3. Now you may thinking these are a small value, anybody can hack. No, let me show you properly. So how I can do, let me go to this one again, protocol and Diffie-Hellman and share secret, click OK, and let me generate prime number. Generate, this is the huge number, it will be like this, and let's generate this one and click OK. You can see a huge value like this, and generate secret key. Let me generate a huge secret key like this, and let's generate a huge secret key, the one which I give an example. This is a small value, and now click OK and calculate, and you can see and calculate a huge number, and they will exchange these huge number with each other. And finally these are the public key which they generate a huge number, and now finally when you calculate, so they will get the same value which ending with 4468. And let's see this one, and let's go to the end. Yes, 4468, and both value are matching, and this is called share secret. So we use this method and we find out share same secret key. So this is the way, and this is very important in side to side VPN. That's why in VPN, when you are trying to configure VPN, okay, enable config crypt, sorry, let me go to config T, crypto, and policy 1, and here is group. That's why we are using these Diffie-Hellman group and router, and similarly we are using Diffie-Hellman here, so that they can exchange the key with each other in unsecure network. So I hope you get the idea why we need Diffie-Hellman, which is very important for side to side VPN, which is very important for TLS and SSL, for SSH, to securely start the communication. And this is the way. So between two parties, if they want to communicate securely with each other, how they will exchange the key. So this method can be used, this algorithm can be used to find out the share secret, and they will never send over the wire, and they will generate the key to use an algorithm. And this algorithm is called Diffie-Hellman because these two scientists developed this algorithm in the year 1976. Thank you.